available for later viewing on the. Oh yeah, thank you very much. Try this again. Thanks, thanks for the talk, Jesse. We've had minor technical problems, but so far we didn't have to click on our pre-prepared technical problems picture, which would have been this. But nope, we're still on track for this, so things are working. And we are also almost on time. And our next speaker is a live speaker, so at least the video is not going to mess up. And he's the CIO of Mousepaw Media. It's Jason McDonald, the author of the upcoming book Dead Simple Python, and he's always a joy to talk to. So, Jason, welcome. And let's see if we can hear something. Yes. Hey. We're still alive here. So after I can hear you perfectly. It's working.
Okay, good. All right, let's see if the screen share works now.
So the next thing, the screen share will work probably because I will click Add to Stream now, and
Yay!
As you can see, it's so nice. So, as we are already 1 minute over the planned starting time, I will let you get through this right away. Start with you're thinking about objects wrong. There you go.
And so is everyone else. Yeah, exactly. So I was preparing for this over the weekend, and I decided I hated my slide deck, so I deleted it, and I went ahead and just went with Visual Studio Code for this. This is a new thing for me. So, I probably don't need to reintroduce myself here. So I'll just get into it to save some time. As Martin mentioned, though, I am the CEO lead developer at Mousepaw Media, and it's worth mentioning that I have been training interns for quite a number of years. So a lot of the stuff I'm going to be talking about is based on teaching them how object-oriented programming was supposed to work. Because the thing is, if we want to find someone to blame for thinking about objects wrong, blame university-style Java. It's not Java itself; it's the way the universities teach it, and it's kind of just kind of replicated over the past 20 some odd years. And it's a very backwards way of thinking about the problem. See, the problem is we missed Alan Kay's point when he started talking about object-oriented programming and objects in general. We kind of misunderstood what he was getting at. But thankfully, we can correct it with the existing tools we have, especially in Python, because it's not really a change in tools, it's a change in thinking. So you already know all of these techniques. I'm not really going to show you any new techniques today, probably. Maybe it'll be new for some people, but most of this you probably already know. But if you're more advanced developer and you're watching this, stick around because I am going to actually make an immutable class at the end. So if you've been wondering how to do that, I'm going to show you. And as Martin mentioned, I'm also the author of Dead Simple Python, which is, I love that book cover. That just makes me happy right there. So Dead Simple Python is a book all about learning the Python programming language when you're coming from another language. So like C++ or what have you, JavaScript or Ruby or Java. And so it helps you learn idiomatic Python. And I there's some stuff in here that I learned in the process of researching it. So even if you've been doing Python for, 10 years, you'll still learn something from this. So this is coming up May 2021 from No Starch Press. Very excited for that. Also, all my notes are going to be on GitHub, so you can find them at github.com, codemouse92, talk_thinking about objects. I'll stick this into Discord later as well. All right, so I'm going to cover three different components I'm going to basically tackle this problem of objects from three different angles. And those angles are blueprint, boundaries, and behavior. Blueprint, boundaries, and behavior. So starting with blueprint being software architecture. Alan Kay, in a message to the Squeak mailing list back in October 1998, said, "I'm sorry that I long ago coined the term objects for this topic because it gets many people to focus on the lesser idea. The big idea is messaging." Messaging is kind of what I'm going to be focusing on here, largely. Messaging is the key of how you need to be approaching object-oriented programming. And the cool thing is this means it's no longer at odds with functional programming. You can do functional patterns with objects as long as you bear this in mind, as you're going to see. But see, the problem is tutorials have historically tricked us into flipping the logic, which is where we get this university-style Java from. Because we all learned object-oriented programming basically the same way. So I'm just going to kind of throw up an example here. So we've all seen this terrible thing. We're going to create a class, boys and girls, as called animal, and then we're going to get more specific, and we're going to create a cat which inherits from animal, and it's going to have a name. And so we're going to name the cat, and the cat needs to be able to meow. And so we'll say print meow. Help if I can spell. And it needs to be able to eat. So we'll have it eat food. And we'll use an F string to be trendy here. Eats food. Great. Okay, so now we can create our cat. And our cat's name is Fluffy. And the cat meows. And the cat eats salmon. Okay, this is insipid. My soul burns with this example, if I'm totally honest with you here. If I just run this. Okay, meow, and it eats salmon. Okay, it's cute. It's also wrong. I've immediately gone completely off the rails in terms of how object-oriented programming is actually supposed to work. Because when you're writing tutorials, this flips the logic on its head, and it's a solution in search of a problem. And of course, part of that's because writing tutorials is hard. I just spent 2 years doing it with this book. Writing examples is very difficult because you have to think, what do I want to teach, and how do I present that? So, what problem can I use? Which can be annoying. So, to get around that, then. Sorry. We have to think about the design of the behavior of the code first. Forget classes. Design the behavior of the code first. So let's get this out of our sight. And I'm gonna build an example here. I got to delete these. I'm gonna rework these. So let's bring this up here. So we have this animal adoption scenario I'm going to build. Present animals who are up for adoption and then automate the adoption process. Most of this is going to be stub functions, but bear with me here. So I need to think about what do I actually want this code to do. Well, I want to be able to do two things. I need to be able to display animals, and I want to be able to adopt an animal. Okay, so how do we do this? Well, let's see. Display animals. This is where objects come in. We have to think about objects as units of state. Objects are messages, by case description, or units of state, if you're thinking about functional. So we start thinking about the messages that we need to pass between the functions. So, for example, we have display animals, and we have a list of animals. We'll just call it adoptables. We need to have... to be able to adopt an animal. Self, animal, or not self, what's wrong with me? Animal, adopter, and we'll say adoption pool. Okay. And then when we adopt an animal here, we need to verify the adopter. We need to process the payment for all the adoption expenses. That's also on the adopter. So that's the message we're passing, as it were. We need to register the animal. And so we need to register an animal to an adopter. And we need to mark adopted some animal. Okay, so I have these here. So I'm just gonna go ahead and put these up here. Oh, it'd help if I could type today. There we go. And we'll just make those blank for the moment. But we have our stubs here, and this is now demanding some things. So let's just pass none for the moment. There's only one argument on the first one, not three. Okay, so if I run that. So the important thing here is that classes are not an organizational structure. We're thinking about this behavior without regard to classes whatsoever, and it's running. It doesn't do anything yet, but it runs. So we're thinking about the behavior first. Now we can start thinking about the messages. That is the classes, because the classes are defined by their constituent data. So I'm going to go ahead and create one of these. We have to have an animal. So an animal, let's think about what the constituent data is for this. An animal needs to have, let's see, let's do our initializer. It needs to have a name, a gender, an age, a breed, and a species. I'm going to just quickly turn these into attributes here. So Control D to, whoops, let's select one of these commas. Control D to select all my commas. That gives me my multi-cursor, and then I can extend my multi-cursor there and copy that self.name equals. One other attribute I want to be able to add in here is notes. I want to be able to store some notes, but we're going to figure that part out later. But I'm not going to supply it now. Where am I? Sorry. Okay, so this is our animal class here. One of the important things to note is that the constituent data is going to inform the structure. It doesn't actually have to be a class. Could it be a dictionary? Could it be a named tuple? Hey, don't cringe. They're neat. Could it be a data class? So example of one with a data class. Let's take a look at adopter. This adopter, I don't really need to do anything special with this. I just need a few pieces of information. That's all I really need. So data class is a good fit for this. So a data class, and this just creates an ordinary class, with this data class decorator. There's some cool features with this if you read the docs. But I'm just going to create a few fields, and these are all going to wind up being instance attributes once the decorator does its magic. So there's an adopter. I have name, government ID, address, phone number, email. Pretty simple. I know that I don't need anything more because this is just an adopter. I don't need any special functionality on this. So I have my adopter. Another common mistake that we make when we're structuring code, though, is we start thinking about, well, how can inheritance work its way into it? Again, it's because of how we're taught. We think somewhere instinctively along the way, well, we have cats and dogs. So we should create a cat class, and we should create a dog class. Okay, here's the problem. This doesn't help us. In this example, the cats and the dogs don't really have any additional data. We say, well, they have additional behavior, but that's exactly the problem. Inheritance needs to extend the meaning, not just the behavior, because again, classes are defined by their constituent data. Everything's about the data. It's all about the data. So we don't need to do that. Now, inheritance does come in handy in many ways. Let's make adoptables.py. I'm cheating a little bit here. There's really no major need for this, but I'm going to use an abstract base class and make an adoptables class. And the reason I'm making this is because I'm expanding on the meaning. I'm expanding on the data. It's not just a collection. It's a collection of animals that are up for adoption. So I can foresee some additional ways I need to work with that data, some additional attributes of that data. But I'm kind of guilty of finding a problem to fit the solution here. But I only have 25 minutes. Nope, that's supposed to be a list. So I'm gonna just create a collection here, and it's got adoptables or adoptable, and then I'm gonna append an animal. Okay, it's basic, very basic sort of thing. But I inherit from collection, and the nice thing about inheritance is it allows you to make a promise about the data via the functionality. You're not making a promise about the functionality, mind you. This is where it's easy to make this mistake. We think, oh, that just means it implements iter. No, it means that it is iterable. This is about the data. The data is iterable. It's also, we know that the data has, it contains things, so we can check if something is in the collection. And it has a length, a number of elements. So adoptable. All right. So there we go. Okay, so this is the period there would be great. Okay, so this is just making promises about this constituent data. The data is a collection. That's why we're using the inheritance. So moving on then to the second point before I go any further is brief word about this issue of boundaries. Alan Kay said the design should be such that there are clear fences that have to be crossed when serious extensions are made. So he's mainly talking about language design here. This is to the Squeak mailing list, but I believe this applies to objects as well. Fences are better than walls in general. And a good example of this was this underscore. There is nothing actually stopping me from being able to go, animal.notes. I can do that if I want to. But this underscore indicates I shouldn't be doing that this is managed by the class. An object should know how to handle its own data. And that underscore says, hey, I'm managing this. You shouldn't mess with it. But here's the problem. Data hiding, which you see in like Java and C++, whatever, is usually a mistake. It overcomplicates things. It interferes with extension. It interferes with testing. It interferes with debugging. One of my interns was working in C++, needed to test how data was being transformed by a setter into the internal attributes of an object as part of one of the unit tests, and had to work around the data hiding, and it was a royal pain. So, in general, data hiding just does not help. Flags are better because it means that you're leaving it up to the user to decide, hey, do I need to cross this boundary? Can be crossed, but they have a warning. Or, taking taking the bugs on themselves at that point. And this is why I prefer this to data mangling. I could do name mangling with the double underscore at the beginning if I want to, but I really only use this for like critical managed stuff that like there's no conceivable reason why this needs to be accessed. It could really mess things up. I pretty much never do that. In general, don't do that. Okay. So then moving on to the third point here, I think I'm doing all right on time. Behaviors. This is really the behaviors of the class itself. The key in making great and growable systems, says Alan Kay, is much more to design how its modules communicate rather than what their internal properties and behaviors should be. And again, we saw this with main here. We're thinking about how these are communicating with one another rather than thinking about what classes do we want. We figure out the messages first. So I can do some of this here. Note I haven't really written any getters or setters yet. Well, okay, I kind of have one here. But, I don't really have many getters and setters. Java would have you write a getter and setter right off the bat and do it for everything. But if you could just access the attribute directly, why bother? Getters and setters have specific purposes. Getters are for data transformation and data filtering. So an example of that would be if we wanted to add a string function to animal, so that way we can print out the animal nicely. This string function, I'm just going to copy from my notes here to save some typing. Okay, so this is just going to transform the name, age, gender, breed, species, and all the notes into a nice little compact string. So this is performing data transformation. It's also technically performing data filtering. We're selecting certain pieces of data to display, although arguably I've displayed them all. Setters, by contrast, are for data validation and data transformation. Example of this is adoptables. If I have a, where's my notes? So if I want to be able to mark an animal as adopted, I have to be able to validate this thing is actually in there. Ask forgiveness, not permission. So I'm going to remove the animal. But, oh, go away. But if, actually, I'm just going to steal this here. If it's not there, then I'm just going to print a nice little error message, and I'm going to need sys for my standard error. So this is a setter because it's performing data validation. This is an example of performing the transformation because it is taking the information, turning it into something else. In this case, appending it to a collection. Properties should not be counted out. Properties are neat. Let's see, where was that one? That's on animal. So with this notes thing, property, I like properties because it gives you a nice uniform interface. Instead of having to remember which thing is a setter method that you have to call and which thing is just an attribute, you can just provide what look like attributes and call it good. It doesn't work if you have to pass a bunch of arguments, but in some cases it works out really super well. I think this is one of those, because maybe this shelter has a policy that you never remove previous notes. I have seen places that do that. You just add new ones, and we're going to transform the data in some fashion, capitalizing the note before appending it to the list of notes. So properties are okay. Again, I'm trying to find a solution, a problem to fit the solution, but you get the general idea. And if we really need to remove from this, we can access notes internally, but I just want to be able to add new ones. So you'll see what this looks like. So because I'm kind of running out of time here, I am going to actually just hijack the fully written version of main. So you can just see briefly what I did here. And that is, here we go. So most of the time you just see I'm accessing the attributes here, but here we're creating Fluffy. It's a 1-year-old female Maine Coon, hates dogs. We have Butch, a 1-year-old male coyote mutt mix. I owned this dog, okay? Coyotes are enthusiastic, friendly, and dumb as rocks. The coyote mixes are just dumb. So I'm going to display those animals, and then I'm going to adopt them. So let's see if all went well. It would help if I actually named something. Oh, yes. I actually have to create adoptables. I just need a global instance here. And that should, yeah, there we go. So you see it prints out the data and then get the payment information register, etc. Now I promised really quick, I think I can just get away with this. I promised I would make something immutable, and I'm going to do that with animal because I want to actually use a set in adoptables rather than a list. But to do that, I need to have it to be hashable, and you really don't want it to be hashable unless it's also immutable. So let's do that. So with animal, the way you can do immutability, and immutability is great because it cuts down on your errors, changing things that you shouldn't be changing. It's an extra level of protection in my mind. So I like immutability. I like to use slots for this. Now, you can just list all of your attributes and call it good. I could just, just do this. And then I like adding weak ref because I like being able to get non-reference counting references, non-counting references. This would be like fully immutable thing, but I'm going to add in here dictionary as well. So we can add this notes and this age because those two things are going to change, but the rest of these things should not be changing. So this is going to be partially immutable. Leave off dictionary and make sure all your attributes are in there if you want it fully immutable. And then I'm going to do set attr, self name value. And the way this works, there's a bunch of different ways people do this, but my personal favorite way is you check if the attribute is already there. And then you also check if it is found in slots. If it is already there and is found in slots, then you raise this attribute error. Otherwise, you call object set attr. Now, here's the thing. Some smart alecks like to point out that this is not actually immutable because you can always use set attr externally to override this. Yes, true. But if you're going to do that, you deserve whatever bugs you're going to get. Python's all about fences rather than walls. We are all intelligent adults. If you're going to bypass things, maybe you have a good reason. Testing, for example, being able to, inject something during debugging or whatever. But most of the time, you just shouldn't be doing that. We also need delete attr. I have actually never seen anyone do this outside of a set attr. So this is just wrong. Okay. All right, and then if we're going to do this, I'm going to go ahead and hash. Make it hashable and comparable. I'm not going to go over that, but we're going to make it hashable, make it comparable with one another. Because I've done this, then I can change one thing here. I can change this to a set, and it still works. We can still add notes, and yet the rest of this is actually immutable. So like name, gender, breed, and species cannot be changed once it's defined. And if I try, I can just say Butch. Maybe he gets maybe someone wants to give him a tougher name. Says, oh, let's name him Butcher instead. And now I'm going to get an attribute error. It's read only. So effectively immutable. It's as close as Python will let you get to immutable without, actually inheriting from a name tuple or some such horror. But there you have it. So I am going to be taking questions in a sec, but I want to make sure. And I have all of this on GitHub, like I said, including the principles here. You design the behavior of the code first. Classes are not an organizational structure. They're units of state or messages, and they're defined by their constituent data. Constituent data is going to inform the structure. Does it actually have to be a class? Could it be something else? And if you use inheritance, that should be extending the meaning, not the behavior. Boundaries, data hiding is usually a mistake. Just use flags. An object should know how to handle its own data, but a user is probably a better expert than you on whether or not they need to get around the fences. Getters are for data transformation and data filtering. Setters are for data validation and data transformation. If it's just a bare getter or setter, except in that one weird case with properties, just don't write getters or setters. Traits of constituent data define the behavior. So things like special methods. Is it iterable, mathematical, comparable, immutable? These things are determined by the data. So anyway, that is, I believe, how object-oriented programming is supposed to work. And the cool thing is it's completely compatible with functional paradigms. So you don't lose your mind as much. So I think I have a couple of minutes for questions here before I have to turn this over.
Yeah. Hey. By the way, thanks for the talk. And so you didn't have to give sacrifices to the demo gods, but you have a lot of animals in there, so maybe they were happy with that. We don't have a real question here yet, but we have at least somebody who has to admit that you managed to hurt his head, so that's good. So Richard,
yeah, well,
I mean, it didn't hurt too much.
Yeah. The property is kind of an unusual thing. It's fairly controversial, but if people don't agree with my use of properties, you can throw that out and keep the rest.
Yeah, and well, we did the practice run yesterday, and I thought when you watch this for the first time, you really get a bit confused. So it's worth just looking it up again and playing it at your own speed to just find out what you just learned. Here's a question. Oh, nice. Let's see. There we go. Any favorite resources in OOP in Python you recommend?
Mine. If I'm totally blunt, the whole reason I wrote Dead Simple Python is because I had a really hard time finding good resources that explained some of these inner workings. I mean, a lot of this came out of, Dead Simple Python. I was researching the inner workings of how things were actually being assigned and how inheritance was working, method resolution order, and all this jazz. And that really changed how I was thinking about objects. Because I was coming from other languages, other object-oriented programming languages originally, where it was kind of more the university Java style, and that's what I was used to. And then I realized that Python does not work that way, and arguably none of the other languages should either. Even if they do have data hiding, that whole university Java style is kind of backwards. So once I understood how Python did things, then idiomatic patterns became more obvious, and then those kind of got retroactively, worked their way into my my C++ style.
We have time for one more question. This time a real question from Richard. Would you not also use a private flag and property to implement effective immutability?
Well, you could, but I would say that's more managed than immutable. Immutable means that once it's defined, that it's not going to change in memory. And granted, what I have is effective immutability because there is that workaround. But the difference is that because you actually get an attribute error when changing on an immutable or an effective immutable, and that's what you want. You want an attribute error. So having the property really just gives you managed data like I have with notes, but it's not going to give you the same sort of thing. Now, I will say really quick that you can you don't actually have to define the initial values of all of these things in your initializer when you're doing this this immutable thing I have. It doesn't wait for it just to be initialized there. It's once there's any value assigned to whatever your immutable, whatever your slot value is. Once there's a value, then it can never be changed. So you can assign it one time. So how you use that is up to you. But yeah, I want to make sure it's clear. There's a difference between immutable and managed.
Okay, thank you very much. I think we don't have any more time for questions. But
I'll be in Discord.
Yes, exactly. You could go over to Discord or follow the next talk here. Thanks again, Jason.
Thank you.